Hi, this is Lab 5, and it's Choose Your Own Adventure, and our adventure was on friction. So basically what I did was I pushed a ball across carpet so that the ball was hit by friction and it slowed down. So basically I used VPython to predict the motion and the time of the ball with that friction, and with that friction we have to add other forces. So basically what it comes down to is finding the coefficient mu for friction in order to predict the correct position as the regular, and mu was equal to 0.0874. So basically important formulas that we used in this lab were F net is not equal to 0 because acceleration is not equal to 0, because as the ball goes across the carpet it slows down and it stops. Because it stops, that means that there is acceleration. So that means that F net is not equal to 0. So so as we use Newton's second law to find the final velocity and the final position, we also have to use the three forces grav, norm, and friction for our model. So some constants that we had were the ball's mass and the ball's position, which was at the origin, and the ball's velocity, which went in the negative x direction, and g is 9.8. So the three forces used in this lab were grav, which is weight, which is negative mg times j hat being in the y direction, the normal force, which is the negative of the gravitational force, and then we have the friction force, which is negative mu times the mag of w times v hat, and v hat being in the x direction. So F net is equal to m plus w plus friction, but we have to recognize that F net is not equal to 0. So basically this is our computational model right here that I made out of Python, and we have the ball going in the negative x direction, and as you can see the friction arrow right there, and it starts out big, but it turns out to be little as it progresses, and as it decreases, the velocity also decreases, making the ball stop. So this is all due to the friction, and it shows in our model correctly. I modeled the normal force to be the black arrow and the grav force to be the orange arrow. And basically the code for these arrows are pretty easy, as it's n times arrow scale and w times arrow scale. But what we have to watch for here is that my friction was negative ball.vel times arrow scale. That too is just for the size of the arrow, but I put it as negative velocity because friction is basically going in the direction of going the opposite direction of the velocity. So we have our model, we have the final model here, I guess. As you can see, this is from Tracker, and the final points match up with the model. And what it comes down to is using trial and error to finally predict that mu. And you know, we found that mu, and it matches correctly with the final point. So here's my real versus computational model, and real is the red dots and the computational is that ugly green color, and we find that the final point matches together. So overall, what did we do? So we predicted the motion of the ball with the friction, and we used Newton's second law. And basically we showed that F net is not equal to 0 as the ball goes across a carpet and decelerates to making the velocity 0. And because we have that friction, we basically had to use trial and error to find the coefficient mu, and that's what we did, and it all matched. So thank you for watching this video, and have a good day.